Welcome to the ICE podcast, supported by the US Soybean Export Council, an initiative to enable the cold chain industry of India to be future ready.
Hello, listeners, and thanks for tuning into the ICE podcast on cold chain technology. I am Manjunath, your host for today's talk. Does form follow function or function follows form? Which one is critical and why? Engineers, architects, designers, futurists, developers are all entitled to this debate on form versus function. As an innovation process coach, I personally would go with function following form. But merely fulfilling function is not the solution. How do we enlarge the function part of this debate? Many years back, when I was into design of clean rooms for pharmaceutical and food industry, I came across an interesting framework to evaluate infrastructure and its components. I began to develop this framework to suit different infrastructure components. There are four fundamental aspects of this framework for evaluation, and I have acronymed it as FDMC. F for functionality, M for maintainability, D for durability, and C for cleanability. You too can use this framework with a little help. You need to do this question and answers 5W plus 1H kind of question and answering, and you can get at some very good, interesting inputs to evaluate an infrastructure. Functionality is critical so that it delivers on what that particular infrastructure is to be used for. So functionality is very critical. Maintainability. See, is it too difficult to maintain? Is it too expensive? Is it too complex to maintain? Durability. Is the fitness for use over a period of time? How useful is this over a period of time? And finally, cleanability. Very important in the food and pharma industry. Is it easy to clean? Will the equipment render well to cleaning agents? How often? How frequent? Several questions can be asked, and then you can do a good evaluation or even a good design. So with this framework in mind, we have today invited an eminent architect to speak on one such cold chain infrastructure component. It is the floors of the cold stores and warehouses. It's my pleasure to introduce Mr. Sanjeev Mhatre, Mumbai-based architect, who is going to be today's speaker. He has spent 41 years designing and architecting several national and international projects. Architect Mhatre is the principal architect of the firm Mhatre Sanjeev Architects and Interior Designers. He has special interests and core competency in designing of civil, industrial, and container freight station infrastructure. He achieves his philosophy of innovative design with the best aesthetic fit and value addition. Architect Mhatre is registered with the Council of Architecture. He is a member of the Indian Institute of Architects, a member of the Practicing Engineers, Architects and Town Planners Association. We look forward to an enlightening talk by Mr. Sanjeev Mhatre. Over to you, sir.
Welcome, dear host and all the participants. I, Sanjeev Mhatre, have been practicing architects since last 42 years, that is from 1978. I, as an architect, have got my tagline as "We shape your dreams." When we design any space, it has to be first functional, and then, as we all human beings would like to have, is aesthetically good looking. Thus, we ensure that these are there in the right proportions, not only functional, not only good looking. When we design any space, that is from small room to a large project, it has to be functional as well as appealing to the user. I take this forward in today's subject of cold storage, in which the functional part is very high and has to be user friendly. The basic requirements of a cold storage are: 1. Safely store and retrieve the goods into and from the cold storage. 2. To store goods at the required temperatures. 3. Handle the goods in various formats, that is palleted cargoes, loose cargoes, etc. as the case may be. 4th, maintain the desired temperatures with almost no losses. 5th, airtight on the four walls, ceiling and the floor. 6th, weatherproof and safe from rains and any leakages from the ceilings or sides. 7. Safety of the persons working in the facility and the mechanical handling equipment. 8. Lastly, securely lockable. Now, looking at the cold storage structure, sides and the ceilings are taken care of in terms of heat loss leakages in a defined detailed joinery in puff panels and application of sealants as per the manufacturer's directions for installation. In case of cold storage, as we all know, the insulation has to be on all four sides, ceiling as well as under the floor. It is to be ensured that they are joined to each other directly, in short, to become a shell. The remaining side is the floor, which has to be done in civil works. The floor is very important in cold storage since it has to be almost of nil maintenance and should have a very long lifespan. Maintenance of any nature except surface maintenance of painting by paint or epoxy is very painful in the operating cold storage and has to be avoided. This is the main difference between insulating panels for walls and ceilings, which can be easily repaired with hardly any downtime or inconvenience during the operation of the working facility. In case of food items and pharma, this becomes more important. The floor has to be mainly designed for taking load of the goods on the floor as well as racking system. Surface has to be smooth for MHs as well as hand pallet trolleys. For the floor, the insulation below the floor is major factor for designing of a floor slab. The challenges are the point loads of the racking system and the moving loads of the MHs. The cold storage efficiency majorly depends on the internal layouts of the anteroom and the chambers and other uses. Thus, these are designed for high density. This in turn reflects on MH's sharp turning and thus the abrasion of the surfaces. The entire floor section has to be designed and the work has to be executed in the desired manner. The section consists of earth filling to the required level, rubble soling or granular subbase, a healthy layer of PCC, that is plain cement concrete, insulation, and in case of frozen chambers, an underfloor heating system. For the top concrete floor to sustain well, all the layers mentioned earlier have to be compacted well to support the floor. Any bad work in any of the layers will result in the main floor sinking unevenly and eventually develop cracks. In view of the above changes, we have to design the concrete floor to take the loads uniformly at all the points. Since this floor is laid on insulation, which is comparatively soft and sensitive to compression, the slab has to be well designed with steel reinforcement to make it, as we call, good for UDL, that is uniformly distributed load. It should become a rigid layer to spread the load rather than transfer it vertically down on the insulation. It should become a solid, flat, single component spreading over the entire area. This spreads load over large area. The entire floor has to be designed and executed with minimal joints. The joints wherever they are to be provided have to be predetermined and designed accordingly. This aspect should not be left to the executing agency during the actual laying of the floor. They have also to be made in such a manner that they become airtight and do not allow any transfer of heat from below. This aspect becomes important as any heat transfer from below will cause the efficiency of the cooling units to drop and in turn run for more time to achieve and maintain the desired temperatures that they are designed for. Running the cooling system longer will result in increased consumption of electricity. And as we all know, in cold storage, electricity is one of the major cost components. The profitability and the viability of the project is at stake. As far as the concrete grade for the slab, it is advised to be minimum M30. Further to the steel reinforcement, we also recommend using steel fibers which binds the concrete at a micro level and makes the concrete free from surface hairline shrinkage cracks. It also greatly helps in areas where there is no reinforcement steel, especially at the edges. The edges have to be finished clean in view of avoiding any accumulation of dirt and also to give ease in cleaning. In terms of the surface, we need to have a proper treated surface. There are various methods to do the same. We recommend a layer of hardener which has to be put when the concrete is laid and leveled by a mechanical troweling method. The dosage is also adjusted as per the chamber heights and loading. Since the spaces in the cold storage are at low temperatures, care has to be taken to ensure that the surfaces are not too smooth to walk and render safe traction to the MHs. There is also a method for surface treatment known as concrete densifier. Though marginally costly, it should be considered as a permanent feature. I would take it as very small percentage compared to the project cost. The finish is smoother and thus the surface can be easily cleaned and maintained in very high hygienic level. Floorings have to be properly finished at the edges of the dock levelers. The other points of ingress of heat are the entries and exits of goods at the docks and the personal movement. Having said this, as you are aware, civil technology is rapidly innovating and new methods, new chemicals are daily being brought in the market with good encouraging results. I strongly say that we should use the latest methods and equipments and be with the present times. With this, I would like to conclude thanking the host and ICE for giving me an opportunity in sharing my knowledge in this subject with you all. And lastly, with best wishes to you all in your endeavors. Take care, stay healthy always. Thanks.